In today's video, we are going to look at notes 9.1, and this is going to be an intro to sequences and series. So it's a lot of background knowledge that you're going to need for the rest of this unit, a couple of definitions. When I give the notes in class, more than likely you will not see this notes page. But just to make the video go quicker, I thought it would be useful. So we're going to get started. Okay, so first of all, what is a sequence? Well, a sequence is a list of numbers that are related by a certain pattern. Okay, so let me give you some examples. All right, so here is a sequence that you might be familiar with. I'm trying to draw a curly bracket, but it's not working very well. Let me try again. Okay, all right, here's a list of numbers that have a pattern to them. Okay, 1, 3, 5, 7, 9, ... That means I want you to keep going forever and ever and ever. All right, well, hopefully by now you've realized that the pattern is that these are odd numbers. Okay. All right, how about another one? What if I say, whoa, that was craziness. All right, how about this sequence? 1, 4, 9, 16, 25, ... Okay, give you a second to think about those. All right. Hopefully you recognize that they are all square numbers. And like they don't skip around. 1 squared is first, 2 squared is second, then 3 squared, 4 squared, 5 squared, and so on. So that is a specific sequence. You can't just skip over random terms. All right, so what is a finite sequence? Finite. All right, well, that is just a sequence with a finite or fixed, or maybe you want to say specific number of terms. Okay, so that would look more like this: 1, 2, 3, 4, and then you close the curly bracket. Notice there's no ... It has a specific number in the beginning and a specific number at the end, and that's it. Okay, whereas an infinite sequence is a sequence with an infinite or unlimited number of terms. And the way we show that, since we certainly can't write them all out, is to put that ... at the end. Okay, so it's got to have some sort of pattern to it. It's not a random list of numbers. All right, so we could either use one that we did in the beginning, or I could give you another one. How about 2, 4, 6, 8, ... That's how I know it goes on forever. All right, well, let's talk about some notation that you need to be able to recognize. All right, when I'm talking about the first term in a sequence, I'm going to use this notation, A with a little subscript of 1, right? And you actually read it, A sub 1. That's how you read it, right? And that means I'm looking at the first term in the sequence. Each subsequent term is denoted by A sub n, where n is the term number in the sequence. All right, so what do I mean? So if the first term is A sub 1, then I mean the second term would be a sub 2. The third term would be a sub 3, and so on. So if I give you an example, here's a sequence 1, 5, 9, 13, 17, and I want you to figure out the following terms. All right, first of all, you need to understand the notation. A sub 1 means I want you to tell me what the first term is. So it's a 1. A sub 4 means I want you to find the fourth term, and that's 13. But look, the next two are a little bigger, a sub 9 and a sub 12. And I didn't list that many for you. So what you have to do is you have to figure out what is the pattern, okay? And you're going to ask yourself, am I adding the same amount, or am I multiplying by the same amount, or something like that? What is the pattern, excuse me, to get from one number to the next? All right, well, let's see. To get from 1 to 5, I add 4. Let's see if I keep adding 4, will that give me the next number? 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. So it definitely looks like the pattern is adding 4. So now I just need to, find some more terms. I'm just going to write them down here. All right, so if I take 17 plus 4, I get 21. Add 4 again, 25. Add 4 again, 29, 33. All right, let's see. 1, 2, 5, 6, 7, 8. Okay, so there's my 9th. But now I need to go to my 12th. So I got to keep adding 4. I did something wrong. Did I make a mistake? No, I guess I didn't. Sorry, something looked weird to me. Okay. All right, and so let's see. 33 was the 9th, 10th, 11th, 12th. All right, so 45 is the 12th term. All right, so hopefully you can recognize that notation. All right, now we get into formulas, because like you're not going to have to sit there and figure out all the terms of a sequence, okay? You can use a formula to find different terms, all right? And we're just going to start by, I'm going to give you the formula. So an explicit formula is an algebraic rule in which the nth term is defined as a function of n. So let's talk about what that means. All right, well, I actually have some explicit formulas here at the bottom. So when I say an algebraic rule in which the nth term, well, a sub n is how I notate the nth term. I don't know what term it is, and so, but it can be any term I want it to be if I know what n is. So it's just the nth term. And look, it's a function that has an n in it. Okay, so it's a function of n instead of perhaps a function of x like we had been doing. Okay, so a sub n is a way to notate the nth term. And then when there's an n in it, that's just a function that you can use to find any term you want. All right, so let me show you what you're going to do with it. All right, these examples say find the first 5 terms of each sequence using the formula. Okay, so think about that. If I want the first 5 terms, that means I want the first term and the second term, third term, fourth term, and 5th term. Now notice what I've done. I've looked at, like, instead of saying a sub n, I've literally done a sub 1, 2, 3, 4, and 5. So what am I technically doing? Well, I'm technically putting this little number in place of n. But if I do it on one side of the equation, I have to do it on the other side of the equation. So I'm going to put 1 in place of the n, okay, in the formula. And then I'm going to plug 2 in place of n. All right, do you get the idea? And then for the next one, I'm going to plug in 3, and then 4, and then 5. All right, but the only thing that can change is the n number. All right, and then I have to actually work them out. I actually have to do the math. Okay, so that should be hopefully easy enough for you. You do inside parentheses first. 1 minus 3 is -2 times 7 is -14. 2 minus 3 is -1 times 7 is -7. 3 minus 3 is 0 times 7 is 0. 4 minus 3 is +1 times 7, and 5 minus 3 times, 5 minus 3 is 2 times 7 is 14. And you should definitely be able to see the pattern. All right, if you look at these, you can definitely see that you get, like, there's a pattern here. It looks like we're adding 7 every single time. Okay, and so the first 5 terms are literally the answers, okay, to these questions. All right, in ALEKS, when you do the homework, it literally just has you list them. You don't have to type in any of this stuff. Okay, now of course that should be on your scratch work so that I can know what you're doing. The more comfortable you get with it, I guess the less work you need to show. All right, so same thing for number 2. I'm going to find A1, A2, 3, A sub 4, and A sub 5. And I'm going to do it by plugging in 1 for n, then I'm going to plug in 2 for n. Whoa, getting sloppy there, sorry. Then I'm going to plug in 3 for n. I'll come back and do that in a second. And I'm going to plug in 4 and 5. Don't forget the square, sorry. Okay, so 1, 2, 3, 4, and 5. So even though I asked you just to list the first 5, I could have asked you for any random term. I could have said, what's the 100th term? All right, and if I asked you for that, I hope you would understand that you just plug in 100 for n. Okay, 1 squared is 1 times -4. 2 squared is 4 times -4. 3 squared is 9 times -4. 4 squared is 16 times -4. 5 squared is 25 times -4. All right, and so the first 5 terms of my sequence are these. Now, it's harder to see the pattern in these numbers, but the formula is the pattern. Okay? All right, so on the next slide here, I just have 2 more for us to work through. And so I'm going to actually pause the video and fill them in, and then I'll go back and talk about them, but I want to point out a couple of things. All right, this one, whoa, sorry, that's really sloppy. The n is in the exponent, and in the second one, there are 2 n's, so you need to change them both. So I'm going to pause the video just so I have time to write out the work, and then we can talk about it. Okay, so I have this first one set up here. I wrote down A1, A2, A3, A4, A5, and then I copied the formula, but every time I saw an n, I plugged in a 1, then a 2, 3, 4, 5. So now I just have to work them out. All right, now if I were you, like just to save yourself some typing in the calculator, or like in Desmos, I would try to work out the 1 minus, the exponent piece first, so that you don't have to worry about that when you get to Desmos. Like actually do the 4 minus 1 and 5 minus 1. Or you can do that part in your head when you type it in. Okay, but you do need to get answers for those. And even though I don't have fractions in any of these, I absolutely need fractions versus decimals if they come up, because you can't see patterns in decimals. All right, so I will tell you that you get 2, -2, positive, or excuse me, you get 1, then -2, +4, -8, +16. All right, and then I'm going to pause the video again and set up number 4, and then we'll come back and talk about it. All right, so here we are. I have notice I have 2 times the n number times the n number plus 1. So I had to put the n number in both spots, okay? And then it's just a matter of doing the math, okay? And that's up to you how much you feel like you need the calculator for. All right, I would probably do 2 times 1, and then I would figure out what 1 plus 5 is, and then that's what I would do the math for, like the actual multiplication. And then I would do 2 times 2, and then 2 plus 5, and then I would multiply those together. Okay, so that's completely up to you how much of that you actually show. 2 times 3, 3 plus 5. Okay, 2 times 4, 4 plus 5. Yeah. And then 2 times 5 and 5 plus 5. All right, so there are my 5 terms. Okay, so hopefully you didn't feel like that was too bad. It just takes a little while to write it all down. Okay, so that's an explicit formula. When the formula is directly given with an n as either the exponent, or you're multiplying by n, or you're raising n to a power, okay? You're literally going to plug these numbers in for n. All right, well, what is a recursive formula? What is a recursive formula? It is an algebraic rule in which one or more previous terms are needed to find the next term. Okay, and I'll explain that a little bit more in a minute. All right, the other thing you need to know for this is that you must be given any previous no, I cannot spell. You must be given any previous terms needed to start the sequence. All right, and then for notation, okay, for notation, let me explain this a little bit. All right, you're going to see things like this: a sub n minus 1. And what that means is it means it's the term before a sub n. Okay? And let me do it even more specifically. Instead of saying the term, I want to be more specific and say one term. One term before a sub n. Okay? If I happen to give you the notation a with a little n minus 2, all right, then that's 2 terms before a sub n. Remember, a sub n is the one you're finding, okay? All right, so let's take a look at an example. It says, suppose that a sequence is defined as follows. A sub 1 equals 14. So I'm telling you that already. And then the formula for a sub n is equal to a sub n minus 1 plus 9. Okay? So this means that to find any term we want, we're going to need to use the term before it plus 9. Okay? And we're going to do that for all n's greater than or equal to 2. So we're going to be starting at 2, and we're going to list the first 4 terms. Now, a sub 1 is still one of the terms in the sequence. So I need to know what A1 is. I need to know what A2 is, A3, and A4. Now, there's two ways to go about this. You can literally plug 2 in for n. All right. So I'm copying it down. The A is still there because the n is part of the subscript. Then you can figure out what 2 minus 1 is. All right. And then you can plug A1, the actual value of A1 in, and get an answer. Okay? All right, so let's do that again with 3. So if I have A3, then in place of n, I'm going to put a 3. Well, then that forces me to do 3 minus 1, but it's still a subscript. And according to that formula, I have to plug in A2 plus 9. All right, so what's happening is that I'm being forced to use the previous term, all right, because this 23 ends up going right here, all right? I'm having to use the previous term to get the one I want, okay, which is the next term, all right? So if you feel comfortable with that, if you understand that that's what's happening, all right, so notice that when I was finding A2, I needed A1 plus 9. When I found A3, I needed A2 plus 9. So if I want to find A4, I'm going to need, all right, so I'm going to skip that part there. I'm going to need A3 plus 9, which means I need 32, which is the last answer I got, plus 9 is 41. Now, if you feel more comfortable actually showing all the steps, you are more than welcome. Okay, so what are the first 4 terms? Make sure you know 14, 23, 32, 41. All right, that is a little bit more of a difficult concept. So of course, I'm going to do another example or two. All right, so suppose that a sequence is defined as follows. A1 equals 6, and A sub n is given by the following formula. 2 times A sub n minus 1, right? So that just means the previous term minus 5. And that starts when n is greater than or equal to 2. All right, so we have A1, so that's going to be the first of the 5 terms that I'm looking for. And then I'm going to have to find A2, I'm going to space this one out a little bit more, A3, A4, and A5. Okay, now if you want to take the shortcut, you just need to understand that whatever term you want, it's going to be 2 times the previous term minus 5. So for A2, it's going to be 2 times the 6 minus 5. I literally am using the previous term. Well, 12 minus 5 is 7. And then if I want A3, then I have to plug in the previous term, 2 times the previous term minus 5. So 2 times 7 is 14, minus 5 is 9. All right, so to find the next one, I'm going to plug in 9 in place of A sub n minus 1. And I'm still going to do everything else. 2 times 9 is 18, minus 5 is 13. And then last but not least, I have to plug in the 13. 2 times 13 is 26, minus 5 is 21. So what are my terms? What are my 5 terms? 6, 7, 9, 13, 21. Okay, and last but not least in this video, we're going to look at one more example. Suppose that a sequence is defined as follows. A sub 1 equals 0. A sub 2 equals 1. So I gave you the first 2 terms. And then I tell you that Any other term you want to find is going to equal, okay, a sub n minus 1 plus a sub n minus 2. So remember, a sub n minus 1 is one term before the one you want. A sub n minus 2 is two terms before the one you want. All right, so I'm going to write this one out the long way. All right, these two are given to me. They are part of my list. And then I want to find A3 and A4. Okay, because it says list the first four terms of the sequence. All right, so if I do it in terms of the formula, I'm putting the 3 in place of n. So let's see what happens when I do that. I get a little 3 minus 1 right there. And I get a little 3 minus 2 right there. All right, well, what is 3 minus 1? What is 3 minus 2? All right, so look what I'm showing you. A3, term A3, is equal to A2 plus A1. That means I'm adding the two previous terms. Okay? And that answer still happens to be 1. All right, so what do I do? What do I get if I plug in the 4? All right, so plug in the little 4 and then do the math. 4 minus 1 is 3. 4 minus 2 is 2. So this is telling me if I want the fourth term, I need the third one plus the second one. Well, the third one was 1, the second one was 1, and so the fourth one is 2. So my four terms are 0, 1, 1, 2. Okay? So what would you do if I wanted the next one? Well, the pattern is you just add the previous two terms. So you would add 2 plus 1. Then you would add 3 plus 2. Then you would add 5 plus 3. And then 8 plus 5. And so that's the pattern. You just add each two, the previous two terms to get the new term. And that's actually called, see if I can spell this right, the Fibonacci sequence. So that's like a famous mathematical sequence. It's used in different code breaking things. If you've ever seen the, shoot, what is that movie? Oh my goodness, I can't think of it. I read the book. Why won't it come to me? I don't know. I'll think of it. Maybe we'll talk about it in class. All right, so I'm going to end this movie here, and then we're going to talk about series. So that's an intro to sequences, and now we have to do a little bit about, a little talk about series in the next video, but the next video will be a lot shorter. Okay, so sorry for this one being so long. The next one will definitely be shorter.